Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 5, where we will solve a problem based on recursion, and the level of this question is going to be easy. The name of this question is POW-XN. You will get this question link in description, and you can also download this Excel sheet from description as well. So without wasting much time, let's see our question. So this is our question on LeetCode. It simply says to implement POW-XN, where POW is the name of the function and x and n are its two arguments, right? Which calculates x raised to power n. So this question is pretty straightforward. It simply says to calculate x to the power n, where x is a double value and n is an integer, right? So let's analyze this problem by taking some examples. Okay, so let's say the value of x, is 5 and the value of n is 3, right? Then we have to calculate 5 to the power 3. Okay, now think of yourself, what is the meaning of 5 to the power 3, or how we calculate 5 to the power 3? What we basically do is we multiply 5 3 number of times, right? So we'll write 5 into 5 into 5, right? And this is nothing but 5 to the power 3, correct? Similarly, if someone says to calculate 5 to the power 4, how we will calculate this? We will multiply this 5 4 number of times. We will write 5 into 5 into 5 and into 5, right? So what we have done, we have multiplied this 5 for the 4 number of times. This is 1, this is 2, this is 3 and this is 4, right? So this is very simple. Now we just have to implement this. Using our code, right? Using code. So how we will do this? Is our next question. So basically what we are doing here is we are multiplying 5 for some specific number of times, right? For this case, we are multiplying 5 for 4 number of times. So what we can do, we can use loop here, right? Why do we use loop? We use loop when we have to do something repeatedly, right? And we are repeatedly multiplying 5. So we will use a loop here. So how we will do this? Let's say our answer is 1 initially, and then I will run a loop for int I is equal to 0 up to the value of n, right? Up to the value of n. And then what I'll do answer is equal to answer into x, right? And at the end we can return our answer. So how will it work? Let's say the value of x is 5 and the value of n is 4, right? And initially our answer is 1. Okay, so for the first time the value of I will be 0, and what we'll do, we'll multiply this answer with x and we will store this value in answer itself. So simply the value of answer initially is 1, we will multiply 5 into it, right? Then the value of 0 will increment to 1. Then again we have to do the same operation, right? So what we'll do, we will multiply the value of x into our answer and we'll put it back into our answer variable. So it means we will multiply 5 again here. Then the value of I will go to 2. We will again multiply 5 here. The value of I will go to 3. Then again we'll multiply 5 here. Then the value of I will go to 4. Now here the value of I is equal to 4, and this for loop will run for I lesser than n, right? I lesser than n. So for this particular time, 4, is it lesser than 4, right? Because the value of n is 4. 4, is it lesser than 4? So we'll say no. Then we will come out of this loop. And then we will return our answer. So what our answer hold, right? What is the value of our answer variable? It is nothing but 5 into 5 into 5 into 5, right? And of course 1. So this 1 will not alter our answer and we'll get our answer, right? So this is one approach which comes in my mind when I see this question. But there is a twist. In the question, if you read the constraints, then there it is clearly mentioned that the value of n can also be negative, right? The value of n can also be negative. Now let's say we have to calculate 5 to the power minus 4, right? Let's say we have to calculate 5 to the power minus 4. So let me just clear it and then I'll explain you. Okay, so let's say the value of n is -4 this time, right? The value of n is -4, and let me also rub this. Okay, so initially when we will come to implement this for loop, then the value of I will be initialized with 0, correct? And here we will have a condition that the value of I should be lesser than n, correct? Now what is the value of n? Value of n is -4, right? The value of n is -4. Then we will compare what is the value of I? Value of I is 0. Now we will see, is the value of 0, the value of I, that is 0, is it lesser than -4? Or if I write it here, then we will do this comparison. This is the value of I and this is going to be the value of n. Now we will see, is the value of I is lesser than n? Is this 0 is lesser than -4? You will say no, this is false. So now in this particular case, this for loop will not get executed, and in the answer we will get 1 because the initial value of answer was 1. So how to solve this problem, right? How to solve this problem? So one thing which I know, that can I write this 5 to the power -4 as 1 to the power 5 whole to the power 4? Can I do this? You will say yes, I can definitely do this. Now if we can do this, right, if we can do this, then we can solve this problem very easily with the same approach. What we'll do, we will simply check what is the value of n. If it is lesser than 0, right, if the value of n is lesser than 0, what we have to do, we have to write x is equal to 1 by x, right? 1 by x. So initially, let's say the value of x was 5, then the value of, let's say initially the value of x was 5, then the value of x will become 1 by 5, right? And then we will do n is equal to minus of n, right? N is equal to minus of n. So let's take the same example. So let's say the value of n is -4 and the value of x is 5, correct? So here we will check, is this -4 is lesser than 0? You will say yes, it is. Then what we'll do, we will put 1 by x into x, right? So now instead of having 5, we will write 1 by 5, right? The 1 by 5 value will be allocated to x variable. Now we will do n is equal to minus of n, right? We'll write n is equal to minus of n. So n is equal to, what is the value of n? The value of n is -4. So minus of -4 will become a +4. So now the value of n will become 4. Now if we just do this much of change in our code, right, if we add this much of code into our approach, into our code, then this particular approach, then let me just rub it, yeah, then this particular for loop will definitely work, right? Then this particular for loop will definitely work and we will get our answer, right? Then how it will work? So the value of x will be initially 1 to the power 5 and the value of n will be 4. So the answer will be calculated something like this, right? We will multiply 1 by 5 for 4 number of times and we will get our answer. Now let's think of what will be the time complexity for this particular solution, right? What will be the time complexity? So basically here we are running a loop from I is equal to 0 up to n. So for this particular approach, the time complexity is going to be O of n, right? Big O of n. And the space complexity will be big O of 1 because we are not using any extra space. But if you submit this particular approach in the LeetCode, you will get TLE, that is time limit exceeded, right? So the current time complexity is O of n, which we have thought of, right? And we are getting TLE for this particular time complexity. Then what does it mean? It means that we have to think of a time complexity which has to be lesser than big O of n, right? It has to be lesser than big O of n. So, okay, so this is what we have to do. Okay, now let's think of how we will do this. So one thing which we definitely know, that whatever we can do with loops, we can also do with recursion, right? Whatever we can do with loops, we can also implement it with recursion, right? So let's try to solve this problem with recursion, right? So now let's think of a recursive solution, how we can solve this. So one thing we definitely know, that if we go for this particular approach, that is, if we have 5 to the power 4, then we'll multiply this 5 for 4 number of times, then the time complexity will definitely be O of n, right? Now we have to make it less, like we have to solve this problem in a lesser time complexity, So now let's think that if I have to calculate 5 to the power 4, can I just divide this problem into sub problems? Can I say let's go and calculate 5 to the power 2 and calculate 5 to the power 2. Go and calculate 5 to the power 2 and 5 to the power 2. Okay. Now if I again solve this, or if I again break this problem into two smaller problems, then I'll say go and calculate 5 to the power 1. Go and calculate 5 to the power 1. Similarly, for this case also, go and calculate 5 to the power 1. Go and calculate 5 to the power 1. So now we definitely know one thing. What will be the value of 5 to the power 1? It will be 5 itself, right? So from here, we will return 5. We'll say, okay, take your 5. Take 5, right? Because the value of 5 to the power 1 is 5, right? Okay. Now here what we will do, whatever we are getting from these two things, right? From these two function calls, we will multiply it. So I'll write 5 into 5. It will become 25, right? Similarly, what will the value of 5 to the power 1? It will be 5. And what will the value of 5 to the power 1? It will be 5. And here what I'll do, whatever I am getting from these two function calls, I'll multiply them. So I'll write 5 into 5, which is 25. Now I will give this 25 to this, right? I will give this particular 25 to this. And here what I will do, I'll again multiply what I am getting from these two function calls, right? So from here I am getting 25, and from here also I am getting 25. So I will do 25 into 25 and I will return it. So in this way we can solve this problem, right? So now let's take one more example, right? Let's say we have to calculate 5 to the power 6, right? Then what I'll do, I'll say I will divide this one problem into two sub problems. I'll say go and just calculate 5 to the power 3 and 5 to the power 3. Now from where this 3 came? So it is nothing but whatever we have here, right? From here we have 6. I just divide it by 2, and what I'll get 3. So I will now call this function. I'll call this function again with this value 3, right? So I hope this is clear. Then what I have to do, here I have 5 to the power 3. Then I'll again divide it into two sub problems. And how I will divide it? I'll say whatever I have here, right? Whatever the value of n, just divide it by 2, right? So what is 3 divided by 2? We will get 1. So I'll do, okay, I'll say go and make a call of 5 to the power 1. Go and make a call of 5 to the power 1, right? I'll do this. Similarly for this call also, I'll say go and calculate 5 to the power 1. Go and calculate 5 to the power 1. So it will give, what is the value of 5 to the power 1? It will be 5 itself, so it will return 5. What is the value of 5 to the power 1? It is 5 itself, so it will return 5. So here what we'll do, we'll multiply this 5 into 5, right? We'll multiply whatever we have got from these two function calls. So we got 5, so I wrote it here. We got this 5, so I wrote it here. And then we'll multiply it. But one thing which you have to take care of, here we are calculating 5 to the power 3, right? But what we are doing, we are just multiplying this 5 for two number of times. But we have to calculate for 5 to the power 3. So what I'll do, I'll say, okay, go and calculate it for one more time, right? So what I will do, I will multiply one extra 5 from my side, right? I will multiply one extra 5 from my side. Now why I will do this? Because the value of n here is odd, right? That's the reason why I did one extra multiplication with 5, right? I hope it is clear. So from here also, what it will return 5, because 5 to the power 1 is 5, and from here also it will return 5. So 5 to the power 1 is nothing but 5. Here at this particular function call, what we will do, we will multiply whatever we have got, right? Whatever we have got from these two function calls. So it is 5 into 5, and it is an odd number, right? The value of n here is odd. So I will multiply one more 5 from my side, and whatever will be this value, I will give it to him, right? Give it to this function call, and whatever the value of this, I will give it to this function call, right? So here what I'll have these 5 3 number of times, and here I'll have 5 3 number of times, right? So it will be 5 into 5 into 5, right? 5 into 5 into 5, which came from this function call, and from here we'll also get 5 into 5 into 5. Now whatever two things which I have got from these two function calls, I'll multiply it again, and I'll return it. So this is one approach, like this is the intuition, right? So let's take one more test case. Let's say the value we have to calculate is 5 to the power 7, right? We have to calculate 5 to the power 7. So how we will calculate this, right? The value of n is 7. So I'll say go and calculate for n by 2, which is 7 by 2, which is 3, right? Which is 3. So I will go and calculate for 5 to the power 3. Similarly, I'll say go and calculate for 5 to the power 3. Okay. So now here, what is the value of n? N is again 3. So I'll say go and calculate for n by 2, which is 3 by 2, which is 1, right? So it will go and calculate 5 to the power 1, and here we will go and calculate 5 to the power 1. Here also we will go and calculate 5 to the power 1, and here also we'll go and calculate 5 to the power 1. Okay. So now one thing which we are very sure, what will be the value of 5 to the power 1? It will be nothing but 5 itself. So here we will return 5, right? What is the value of 5 to the power 1? Nothing but 5 itself. So we will return 5 here. Now the value of n here is odd. So what I'll do 5 into 5. Why? Because this one 5 which I got from this function call, and this is the other 5 which I got from this function call, and I'll do one more multiplication with 5. Why? Because this was odd, right? This was odd. Similarly, here also we'll calculate 5 into 5 into 5, correct? And then what we will do, let me just rub this. Yeah, so what this function will do, what this function call will do, whatever it will get from this right, from this function call, and whatever it get from this function call, it will multiply it, right? So here we will get these 3 5s, this 3 5 multiplication, and this 3 5 multiplication. So it will do 5 into 5 into 5, which I got from this, and from here also I am getting multiplication of 5 for 3 number of times. So I'll do this and I'll multiply it, right? But what is the value of n here? The value of n here is odd. What does it mean? It means that I will multiply one more 5 from my side, and in the answer I will return this. What is this? It is nothing but we have multiplied 5 for 7 number of times. This is number 1, this is number 2, number 3, number 4, number 5, number 6, and number 7, right? So in this way we will solve this problem. So now I hope the intuition or the idea behind this approach is clear into your head. Now let's think of the solution. Let's think about the code. So we'll make a function int solve, and here we'll have two values, that is int num, and we'll have one more that is int power, right? So this n is nothing but the x which was mentioned in question. This power or POV is nothing but n which was mentioned in the question. Okay. Then at each step, what we are doing here, for the each step, what we are doing, we are just dividing our problem into two sub problems, right? We are just doing this thing. So we'll do the same. What I'll say go and calculate. So instead of return, I'll say go and calculate num and power by 2, right? And also go and calculate num and power by 2, right? And then just multiply them. So I can write it right like int a is equal to this and int b is equal to this, and just return a into b, right? And we also have to write a base case that if the value of power is equal to 1, then what we have to do? We have to return the number itself, right? We have to return the number itself. So this is very basic and a very basic and straightforward approach. But what will be the case when the value of power is odd? What we have to do in that scenario, right? What we have to do in that scenario. So what we'll do, instead of writing return a into b, writing return a into b, we will check the value of power. So if the power is even, right? If we divide by 2 and if we are getting the remainder as 0, it means that the value of power is even. If it is even, then I will simply return a into b, right? And if it is not even, if it is odd, then what we will do? We will return a into b into number itself, right? So this is the complete code, right? This is the complete code for this particular approach. Now what will be the time complexity for this particular approach? See, for every function call, we are making two different calls, right? Two different calls. So let's say that this is one function call, then from here we will make two different function calls. From this function call, I will again make two different function call. From this function call, I'll again make two different function call. From here, I will again make two different function calls. So what will be the time complexity? In this particular scenario, the time complexity will be 2 to the power n. 2 to the power n. Why? Because for every function call, I am making two more function calls, right? Two more function calls. Now, one thing which we have to think about here is, in our previous solution where we have solved it using loop, there the time complexity of O of n, right? And with that particular approach also we were getting TLE, right? Now the time complexity for this particular approach is 2 to the power n, right? And you easily can see that the 2 to the power n will definitely be greater than O of n. So basically means that time complexity for this particular approach is greater than the time complexity what we had computed using loop, right? So if I submit this, I will again get a, not runtime, I will again get a TLE, that is time limit exceeded, right? So we have to optimize it. So let's see how we can optimize this approach. So before that, let me rub all this. Okay, so let's see how we can optimize this. So see, for every function call, we are making these two calls, right? And what these two calls are doing, these two calls are exactly same. Isn't it? Here also the value of power is power by 2. Here also the value of power is power by 2, and the value of num is also same here. If I show you here, so let me just rub it off and make it clear so that you can understand it in a more better way. Okay, so see, from here we made a function call 5 to the power 3, and we again made a function call for 5 to the power 3, but these two are exactly same. Right? Similarly here also we made two function calls for 5 to the power 1 and 5 to the power 1, and they are also same. So instead of making two function calls, what I can do, I can omit this, right? I'll say, okay, go and calculate only one function call, right? Go and calculate only num power by 2, and instead of multiplying a with b, because for right now we don't have any b, so what I'll do, I'll write go and multiply a with a itself, and I'll say go multiply a with a itself here also. So now how this function, like how this will work, okay? So let's analyze it. So let's say we have 5 to the power 4, then I made a call for 5 to the power 2, and then I made a call for 5 to the power 1, correct? And this is nothing but our base case. So whenever the value of power is 1, what we will return? We will return 5 to it. we will return 5 to it. Now here what I am doing, I am doing a into a, right? And what is this a? What is this a? This a is nothing but whatever this function is returning, it is a. So it will return 5 and it will return 5. So what it is 5 into 5. 5 into 5, what the value of 5 into 5 is 25. Now we will return this to this function call. Here also what I'll do, whatever I have got from this function, I'll multiply it. So from here I got 25, which will be stored in value a, in variable a. Then I will again multiply it with 25. Again I will multiply it with a, and then I will get my answer, which is going to be 625, right? So this approach is more efficient. This approach is more efficient. And now the time complexity for this approach will be big O of log of n, which is indeed lesser than O of n, right? Which is indeed lesser than O of n. Now if you are thinking about how the time complexity of this solution is O of log n. How? Because we are just dividing the value of power by 2, right? We are just dividing the value of power by 2. So initially it was 5. So sorry, let's say that initially it was 4. Then we made a call for 4. Okay, so 1, 2, 3, start. So let's say initially the value of n is 8, right? Then we made a call for n by 2, which will be for 4, right? Then we again made a call for n by 2, it will go for 2. Then we'll again made a call for n by 2, it will go for 1, right? So this is the scenario where we say that the time complexity is log of n, right? So here I am not going to derive the time complexity, right? I hope you can understand this. So now without wasting much time, let's code it up. Okay, so now we are here back to our LeetCode. So let's solve this. Let's code it up. So initially what we have to do, we have to check, right? We have to check that the value of n is positive or it is negative, right? So what we will do, let's say we have a variable int num, which is nothing but x itself, and we have one more thing, int power, which is equal to n itself, right? Now we will see if the value of n is lesser than 0. If the value of n is lesser than 0, then what we will do? We will do, right, num is equal to 1 by num, right, and pow is equal to minus of pow, correct? This is what we have done. Now what I'll do, I'll simply do a function call and I'll return it. I'll return whatever this function will give me, I will return it. So I will send num and pow here as an arguments, right? But one more thing which we have to see, and one more thing which we have to take care here is the value of x is double, right? The value of x is double. So here instead of having int, we will write double. Okay, then let's write this solve function. So it is going to be very easy. The return type will be double, and here we'll write solve, and then we will have double num and integer pow, right? Then firstly we'll write our base case, that is if pow is equal to 1, then you have to just return your num variable, right? Then I'll write int. Instead of writing int, I will write double. Why? Because this solve function will give me a double value, right? A double value. So I will write double a is equal to solve num and pow by 2, correct? Then I will check if the pow, value of pow divided by 2 is equal to 0. It means that it is an even number. If it is an even number, I will simply return a into a, correct? And else if it is odd, then I will return a into number itself, right? And if I run this code, I should get the right solution, the right answer, but here we have some compilation error. So okay, so here there is a spelling mistake. We will have POW. Okay, so now you can see that all the sample test cases are accepted, But if I submit this, I will get a runtime error. Let me just show you. See, here we are getting a runtime error. Now why we are getting a runtime error? So here you can see that if the value of n is 0, then what we have to do? We haven't thought about this, right? If the value of n, that is if the value of pow is 0, then how this function will work? It will go into kind of infinite loop, right? Because we will do 0 by 2, then we'll again do 0 by 2, again we will do 0 by 2, again we will do 0 by 2. So the value of this pow will never be equal to 1, right? So what we have to do, we have to write here that if my n is equal to 0, then we have to return 1. Because why to do this? Because we all know that if we have something x to the power 0, then the answer will always be 1, right? The answer will always be 1. So this is the reason why we have to do this. This is the reason why we have to return 1 here. Now if I take this, if I use this test case, and now if I run this, I should get the right answer. Yeah, here you can see that this test case is also passed, but if I submit this, I will get a runtime error again. Okay, so this is the case I was talking about. So here we got a runtime error, and here the value of n is this, right? Here the value of n is this. So let's think of why we got this runtime error and how to solve this. So in the question, if you go to the constraints, if we just see the constraints, then here we can see that the value of n can be minus 2 to the power 31 to 2 to the power 31 minus 1, which is nothing but the limit of integer variable, right? So we know that in an integer variable, the minimum value which we can store is this, which is minus 2 to the power 31, which is nothing but this, and the maximum value which we can store is 2 to the power 31 minus 1, which is nothing but this. Okay, so now let's say we have to calculate 2 to the power minus 2 to the power 31, right? So let's say this is nothing but this is 3 here, right? Yeah, this is the value of n, right? This is the value of n. Then in our code, what we are doing? Let's see. So I think yeah, here it is. So if the value of n is lesser than 0, we are doing n is equal to minus of n, right? N is equal to minus of n. So we are writing something like this: n is equal to minus of n. It means that n is equal to minus of 2 to the power 31. Then it will become plus 2 to the power 31, right? But what is the maximum limit of an integer variable? The maximum limit of an integer variable is 2 to the power 31 minus 1, and here we are having 2 to the power 31, which is greater, right? Which is greater than the limit of an integer, right? It is greater than the limit of an integer variable. So what we have to do here, what we will do, instead of using integer, we will use long, right? We will use long, right? And then we will solve this problem, and then we will not get this runtime error, right? Will not get this runtime error. Okay, so let me just do the changes here. So we know that instead of having int, we will have long, right? We will have long here. And even here, instead of having int, we will have long, right? And I don't think I have to do changes more. So yeah, let's run this and then we will submit it. Okay, so all the sample test cases are passed. Let me just submit this. Okay, so now you can see that it is accepted. So this was all for day number 5, where we solved this problem. And I hope you like this video, you like this approach. If you have any other approach, then please comment down your approach. And if you like this video, if this video was helpful for you, then make sure you like this video, make sure you do a comment and you subscribe to this channel. Thank you. We will meet again tomorrow with a new question.